Good morning. Looks like it's going to be a nice day. So let's start this last Zoom supporting the infectious diseases assignment. First of all, I'm going to share with you the brief again so that we know exactly where we are. So here we can see, all right, indicative, so up to, that means 3,500 words. It's a 6-credit graded assignment, okay. Here we have the assessment criteria laid out, and we've worked our way steadily through this, and I've used this plan throughout. In our third PowerPoint, we looked at 5.1 about the use of drugs, antibiotics, antivirals, and antifungals, where we saw that these drugs target particular structures within each of these categories of microorganisms, and that the reason why antibiotics don't work on viruses or fungi is because they are structurally different. Similarly, antiviral drugs don't work with bacterial or fungal because, again, they are structurally different. And we have to point that out in your booklet. We're now moving on, all right, from the cell and human humoral immunity, where we looked at the B cells in the humoral immunity, which produce antibodies, and the cell-mediated, where they produce cytotoxic cells, which actively destroy our own infected cells when they're recognized as being infected. We then ended PowerPoint 3 on the primary and secondary immune responses, but we're now going to carry that over into this video and PowerPoint, because we're going to build on the response to the body of an infection to antigens by the B lymphocytes, and how we have developed a technique known as vaccinations to make use of exposing the body to these antigens in a safe way, so that our body can produce these B memory cells. So we have a blueprint or a template. Now, those are two important words to include: a blueprint or template of the antigen response, so that we can the body can quickly produce antibodies in response to our vaccination and injection. Okay, so we look at, first of all, our PowerPoint, and I will now share that. Again, this can be found on the VLE. So, as it says in our last PowerPoint, we looked at the B lymphocyte cells and the T lymphocytes and their role. Now, our memory cells allow us to have a library of antibodies that we can produce, all right, when we're reinfected with exactly the same microbe. And remember, they're looking for these protein antigens on the surface of our bacteria or our virus or fungus. Okay. It is controversial, is vaccinations. As we know, there is a movement for vaccinations. Vaccination isn't a new thing. Way back in the late 1700s, an English doctor known as Edward Jenner, I think it was around Shropshire way, he actually lived in a time where smallpox was rife, and it killed not hundreds or thousands, but globally millions of people. Smallpox was a devastating disease. And in fact, when Europeans migrated to other parts of the world, we decimated native tribes because they'd never been exposed to smallpox. But Edward Jenner noticed that the milkmaids used to get a milder version of smallpox known as cowpox. And what he did was he took the pus from one of the blisters, because pox produces a blister, and he took the pus and he did something which we would now see unethical, but he took this and scratched it into the skin of a small boy, okay, and lo and behold, the boy gets cowpox. He did then something even more unethical by today's standards, which would be he then took pus from someone from smallpox, scratched that into the skin, and we found that they didn't get the smallpox. So that work was the early start of vaccination. Now, technically, that's not an injection, so we don't call it vaccination. It has the word variolation. If you want to read it, all well and good, but don't preoccupy yourself in the assignment on that. So, over that time, we've now seen, all right, with people like Pasteur in France, etc., that started this idea of vaccinations. And we started getting mass vaccinations in the last century, and we found that they had a profound effect on saving lives. It's very effective. Now, people that point to the dangers of vaccination, it all comes down to a study in the last 20 years of, 30, 40 years, of a doctor based in this country who started to say that the MMR vaccine caused a link to autism and that it shouldn't be given. In fact, it's a fallacy. It unfortunately continues on the internet, but he falsified all these results just so to get notoriety, which is a shame. That doctor lost his license. He's no longer allowed to practice as a doctor for falsifying that data. We as scientists and health professionals must use data and analyze it very, very carefully. We then publish our papers, who then distribute it around the world, and our peers, our fellow professionals, they review it, and scientific and medical professions then look at the evidence and say, yes, we agree, or no, this is flawed. And so therefore, all right, we get to the point where we say, yes, this is fine. Now, since that introduction of worldwide vaccination programs, millions of people have been protected against potentially fatal diseases. We've eradicated smallpox. There's only 3 places that you can find smallpox, and they're all in labs. And we study it and we keep it there so that we can learn more and more from it. But in the world, there is no smallpox. Never hear of smallpox outbreaks. So, vaccinations, we're all familiar with the flu vaccine, now the COVID vaccines. And people are afraid of the new technology with the COVID vaccines. But again, there is evidence that to support the fact that they are very effective. All vaccines will have a slight side effect, sore arms, feeling ill, because your body's getting used to producing antibodies to the antigen that's been injected into you. Okay, but the important thing is it's exposing you to the antigen. Okay, and therefore the vaccination gives you immunity without having to experience the disease or its major symptoms. And there's a reference there at the bottom of the page, okay, to look at this. So my doctor, Cirrus Media, 2000 to 2015. So moving on quickly on to the next slide. Each vaccine contains either a killed or weakened form of the organism. You might find in your research that the word weakened means attenuated. Okay, so that means it's been partially killed. So it's not really functioning. It won't give you the disease. And that's sometimes why you feel a little bit ill, because you get a few symptoms of the actual disease. And killed viruses, they've actually killed the bacterium or the viruses, because we're only interested in the proteins on the outside and the antigens on the outside of the virus or bacteria to poke our immune system into responding. So even though the vaccine has been altered, it won't make you seriously ill. And it stimulates the antigen, the antibody body production, okay? Remember, an antigen is just a foreign protein on that surface, okay? An antigen is specific, all right, and it induces a specific antibody response, which can then bind to it. Now, those are made by the B lymphocytes, okay? Now, the antibodies help to activate the T cells as well that will destroy, all right, our bacteria, our virus, or infected cells. So it helps protect us against those diseases. What types of vaccines? Well, as I say, there's the live, the attenuated vaccine, which contains a living but weakened form of the germ, the inactivated vaccines, which have killed forms of the organism, or the subunits. It's been broken down and it's parts of the organism that have been injected into you. Also, we can have specialized one called toxoid vaccines that actually help against the toxins that produce against by these bacteriums. COVID vaccines, as I said, use this new technology of mRNA, and these vaccines teach our cells to make proteins that will trigger an immune response. Now, although they're new release into general use, they're not new to scientists. They've been around for some years. Now, I've got here an actual link at the bottom of the page, the CDC, that's control for, the Central for Disease Control in America, highly renowned. So it's a great reference to use. Click on it and have a look at the MMR vaccines and vaccinations and the different vaccines, which is where I got the information above from. Live vaccines can provide lifelong immunity after only 1 or 2 doses. Periodic boosters, as we know with the COVID and the flu, are needed to maintain immunity. And that's because these pesky microbes mutate and they change the actual antigens. And so therefore, the antibodies that you did produce that react to those antigens are no longer of any use. So the body has to adapt and they have to make new antibodies. And that's why we have to change our flu jabs and our COVID jabs, any vaccination, because some mutate. Going back to smallpox, for some reason, never mutated, so we never had a worry. That's why we could eliminate it so very quickly, okay? But unfortunately, viruses, okay, mutate quite rapidly, as we've seen. We had the alpha, all right, the beta, the delta, the omicron, okay? We've had all of these mutations over 2 years of the COVID virus, and we have to keep adapting the viruses. Luckily enough, the mRNA ones are very easy to adapt compared to the old style production of vaccinations. So here is a list again from the CDC list, and there's lots. Okay, now because you're doing a booklet for overseas students, I would look at ones that are not only common here but also over in different countries. Now I will kind of like pick out these, all right, in particular. So chickenpox is worldwide, so's mumps. Hepatitis, you can see there's hepatitis A and B. There is also a C. Rubella, pneumonia, pneumococcal, measles, influenza, tetanus, human papillomavirus that can cause cervical cancer, diphtheria, polio, meningitis, meningococcus, and yellow fever. All of those are worldwide, okay? And of course, in this country, our children can be vaccinated with the triple vaccine. And this was the controversial one, the MMR vaccine, that doctor falsified results, all right, to get publicity, money out, book reviews, etc., speak tours, all kinds of stuff. But that's all been debunked now by science. There's combined, the MMR is a combined measles, mumps, and rubella. Okay, all right. Rubella would be things like German measles. Mumps we all know of as the glands swelling up. Now, you must copy this into your assignment for 4.1, because if I just go back to the brief, okay, here it says, copy the table into your booklet and complete it, distinguish between passive and active forms of acquired immunity. The first row has been completed as an example, okay? So naturally acquired active immunity, so naturally acquired, in other words, you've caught it. If you suffer from chickenpox, all right, and twice, I know some of you in class have said it 3 times, chickenpox as a child. So that's naturally acquired. So you've built immunity from being exposed and having the disease. So you need to then give an example, and there are definitions to come in our PowerPoint. So that table must be included. And at that point, you've beginning to finish your assignment. So let's go back and finish off. So here's the table. Now, if you look, you can actually take the table, if I right-click on it, and you can cut and paste it into your assignment. So here's the definitions. Naturally acquired active immunity occurs when a person is exposed to live pathogens. You develop the disease, and that develops your immunity, as in the chickenpox caught by a child. Sometimes, if you want to use a one for overseas, typhoid and cholera, still outbreaks in the world, and that's from drinking water. And so you drink it, you get either the typhoid bacterium or the cholera, and you're exposed to these, and hopefully you survive, but you get some partial immunity. Passive natural immunity is where you acquire it naturally, but you yourself haven't done anything, and that's usually in the placenta, okay, during pregnancy, when the placenta can transfer one of these immunoglobulins. So these are the antibodies, immunoglobulins, and in this case it's IgG that's actually transferred generally in the last 4 to 6 months through the placenta, so that the baby has some sort of immunity when they're born, okay? That immunity will be in full strength by the time they're 5. Now, IgA and IgG are found in human colostrum. That's the first breast milk fed to babies. That's why they encourage women to breastfeed. And you can point that out in your booklet to the foreign worker, that it is important, but also to take note that some women do find it difficult to breastfeed. But the colostrum is very important. Okay, for the naturally acquired immunity, there is the biology textbook there, and there's a hyperlink if you so want to have a look at the website and use it in your reference list. Okay, moving on. Artificially acquired active immunity. Artificially means you have to go out and do something about it. And that occurs when your body becomes immune to disease after being vaccinated or exposed to what will become an infection in future. So sometimes we used to have, when I was a young lad, we used to have mumps parties, or we'd have measles parties or rubella parties. That, there was many a mum used to say, oh, my daughter's got German measles, and they used to come like say, oh, right, well, have a little party and then they can all get it. Sounds weird, I know, but it's better to have German measles as a female when you're younger, because if you get it while you're pregnant, it can cross the placenta barrier, can cause deafness in newborn children. So that's what they used to do. Artificially acquired passive immunity is if a patient is giving antibodies, that's directly through blood infusions. Now, these are grown, the antibodies, in a lab. Sometimes they're used for cancer treatments when a person is undergoing cancer treatment and their immune system may be at a very low ebb, so they give antibodies in the plasma to help them as their body is going through the cancer treatment, because their immunity might well be compromised. It's also used in, has been used in COVID-19 patients where they were given antibodies. They're still investigating that treatment and how well it actually worked. Now, this is an overall picture of immunity. we have what we call innate. In other words, you're born with it. The adaptive, you've got natural and artificial. And in each case, there is a passive and active form of natural and artificial immunity. Okay, last slide. Okay, throughout all of your assignment, please ensure you use relevant examples for overseas health workers. Make sure you've got good diagrams, charts, tables. You can use some of these diagrams here. Look on the internet. Make sure you reference all of them. It must be your own work. Do not use these slides. Please get used to doing your research, because it's an important skill for you when you move into uni. Okay, use an appropriate format. I would use A4, put a front sheet on, looks nice. Okay, referencing text, if you please, and provide a bibliography reference list at the end in Harvard reference, in alphabetical order. Put your word count before the references, please, at the bottom, because I have to check your word count, and it's so much easier to put your word count on the bottom and I just sign it off to say, yes, that's your word count. Okay, so that's it. I'm going to stop sharing. Well, behind me looks like it's a good day, so I'm about to go off into the garden and see if my sweet corn plants are growing nicely, and then off to Slimming World. All right, make sure that I've kept the old weight off. You have a good weekend. I will have emailed this link to you, and I'm also going to email the link to the pharmacology videos, okay, that I've done, which are also Zoom. So that way you can make a start. I will cover the pharmacology PowerPoints, and there's 2 of those. It's actually one PowerPoint, but I split it into 2 videos. Okay, have a good weekend, folks. Always email me if you need help. Okay, bye.